Today's lesson will be 3.6 types of triangles. We're going to have 6 different types of triangles. We're going to classify triangles by their side lengths, and we're going to classify triangles by their angles. So first, let's classify triangles by their side lengths. The first one would be the scalene triangle. What does that mean? No sides are congruent. They're all different. Number 2 is the isosceles triangle. Which means at least 2 sides are congruent. At least. So could all 3 sides be? Sure, it could be. But that has a special name, and that is the equilateral triangle, with all 3 sides congruent and all 3 angles congruent. Next, we're going to classify triangles by their angle measures. The first one is acute triangle, and that means all angles are acute. The obtuse triangle is next, which says one angle is obtuse. Can you have more than one obtuse angle in a triangle? No, because then you'd be over 180 degrees, and that can't happen. And the last type of triangle is the right triangle. And that has one right angle. You can't have 2, because once again we would be over. The right triangle has the right angle. It'd have a box in the corner. The 2 sides are legs, and the side across from the 90-degree angle is called the hypotenuse. Okay, so these are the 6 terms that you need to memorize or be familiar with. We have 3 examples to do. Example 1, we have a triangle. Draw it for me. I'm going to label it as ARK. One side is 6x minus 19. The other one is 3x minus 3. And the last one is x plus 7. Also given is that the perimeter is equal to 35. We want to solve for x and classify the triangle by its sides. Well, what do? We notice that all 3 sides have to add to equal perimeter of 35. So if I add up this piece, and this piece, I get a 10x, negative 19, negative 3, and positive 7. Give me negative 15. Set that equal to 35. So x equals 5. We solve for x. Now we want to figure out what type of triangle it is. Well, when I plug it in, here's A, here's R, here's K. When I plug it in here, I get the answer of 11. When I plug it in here, 12. Plug it in here, I get 12. So what type of triangle? It is the isosceles triangle. Can we classify this triangle by its angles? No, because we don't know anything about the angles. We're not given the angles, we're only given the side lengths. Let's keep going. We have example 2. We have a triangle again. This time we got NBC. This side is 10. This side is 3x plus y. And we got x plus 2y. Our given information is that triangle NBC is equilateral. We need to solve for x and y. All right, well, looking at it, what do you notice? You notice that this statement here has an x and a y, so does this one. So when you see a statement having an x and a y, you know it is a system. So we're going to set 3x plus y equal to 10 because you know it's equilateral, so all the sides are congruent. The other equation would be x plus 2y equals 10. There's the system we have set up. Let's solve it. Let's get rid of the y, so I'll multiply the top one by -2. So we get -6x minus 2y equaling -20. The bottom is x plus 2y equaling 10. -5x is equal to -10, so x equals 2. We need y. I'm going to plug this back in. I'll say here. So we get 2 plus 2y equals 10 minus 2 over 2y equals 8. So then y ends up equaling 4. So my answers were x equals 2 and y equals 4. The last idea we're going to look at is using this idea in a proof. So we got example 3. We are given this picture. We have A here, B, C, D, E, F, and G. Our given information is that angle B is congruent to angle G. Angle 1 is congruent to angle 2. BD is congruent to EG. And AC is congruent to CF. We are trying to prove that triangle CDE is isosceles. All right, so let's look at the given information. Our goal is to prove that this triangle is isosceles. What that means is that two of the sides are going to be congruent. What we need to do is we need to figure out how to prove the two triangles. Well, if we look at it, we got angle B congruent to G, angle 1 congruent to angle 2, and BD congruent to EG. Well, sure, we can prove these two big triangles because you know that this piece right here is reflexive. We can add to get this side and this side, and we can prove this triangle congruent to FBD and ABE because of angle, side, angle. So let's do that. We have angle B being congruent to angle G given. The side, we had BD being congruent to EG. We are adding the reflexive piece, so we got reason 1, DE is congruent to DE. Bracket them together. Reason 2, BE is congruent to GD. And the other angle was angle 1 being congruent to angle 2. All this together, reason 3, we just proved triangle ABE being congruent to triangle FGD. Now where to go from there? We want to prove this isosceles. Well, to do that, we need two sides congruent. So maybe we can get this side here congruent to this side here. But that's not the whole side. But wait, we haven't used this given yet. AC being congruent to CF. But since we proved these two big triangles, anybody have a thought? If you thought that you can prove from CPCTC, AE would be congruent to DF, and then you subtract AC and CF to get CE and CD, you were correct. So for reason 4, we would say AE would be congruent to FD. Underneath that, we'll put AC being congruent to CF, because that was given. These two together, reason 5. Oh, I'll put up my wall because I'm running out of space. So reason 5, we can say CE is now congruent to CD, which then means I can end with triangle CDE is isosceles. We need our 7 reasons. Reason 1 is reflexive. Reason 2, we did addition. 3, angle side angle. 4, CPCTC. 5, we then did subtraction. And 6, you know what it means to be isosceles because we just talked about it. So we got definition of isosceles triangle. There's your lesson on 3.6. You have a small assignment tonight. You have time to work on it now. I expect you to be working on it now. And good luck with memorizing the scalene triangle. No sides are congruent. The isosceles triangle, at least 2 sides, but could be 3. And when you have all 3 sides congruent, it's the equilateral triangle. And if you're trying to classify it by its angles, all angles are acute. It's an acute triangle. One obtuse angle gives you an obtuse triangle, and one right angle gives you the right triangle. Good luck to you.